LangChain is a framework for building reliable AI and agentic applications. It chains together language models to various components such as tools, data, and memory. If you have heard of it but have never used it because too many tutorials with long lines of code seem overwhelming, I have good news for you. It's actually pretty straightforward to use LangChain as long as you understand the logic behind how it works and how to chain components together. So this video will be a no-fuss introduction to how you can set up a reusable LangChain workflow like a blueprint or template so you don't have to reinvent the wheel every time. This way, instead of writing every project from scratch for any task, you just need to change the parameters and arguments, or add other components like Lego pieces, but without the pain of stepping on a piece at 3 a.m. And at the end of this video, we will put it to the test with two useful workflows. This is going to be the first tutorial in our LangChain series, so stick around for more videos. But before I jump into the main part of the tutorial, I'd like to clarify the differences between LangChain, LangGraph, LangSmith, and LangFlow that you might confuse. If you already know these, feel free to skip ahead to the next section. Both LangChain and LangGraph are Python libraries for building AI agents, but LangChain focuses on a simpler linear chain of components between prompts, memory, and agents with basic tool integration. It's ideal for straightforward applications like chatbots, document search, and simple Q&A systems that follow predictable do this then do that sequences. LangGraph extends LangChain for more complex and cyclic workflows, which include loops, branching logic, and multi-agent coordination using a graph-based structure. It's better for dynamic applications, which need human-in-the-loop capabilities and long-term memory and context. So these two are very similar in functionalities but with different levels of complexity, whereas LangSmith is a completely different platform for more serious development, including testing and debugging, for finding the problematic parts and monitoring it to see how it would look like and work in actual production. Finally, LangFlow is just a drag-and-drop interface for prototyping your entire app visually, but at the time of this video, it cannot run the agents or perform an actual task. It's basically a visual builder with a clean UI that lets you chain components together without coding. But something cool about it is that you can export your agentic flow design into LangChain code. That said, in this video, I'm going to only focus on the core logic and structure of LangChain and all important parameters you need to make a universal template that you can reuse for all of your tasks. After this section, I will show you two code demos based on this reusable workflow for two different tasks that you can follow along. A typical LangChain workflow follows a pattern called REACT, which stands for a series of reasoning and action steps, like this one. First, it reasons that it needs certain information about topic X. Second is an action of finding a tool that can give it the information it needs. Third, it asks the question about that topic, then obtains the results. Next is another reasoning for analyzing the results, and so on until it reaches the final answer. As you can guess from this pattern, the logic of a LangChain workflow revolves around this linear flow of chaining the input or prompt to a language model, then constructing memory for tracking the context and chaining it to a tool, followed by forming an agent that executes the task and produces an output. So the core of any LangChain workflow has four main components. I made an acronym for it so you can remember it better. LaMTA, language model, memory, tool, agent. Everything else is setting different parameters of LaMTA or adding additional components to it. For example, additional tools. Easy to add, easy to swap, and way less fragile than IKEA furniture. I'll show you how this works in a second, but for now, let's recap the core logic of LangChain. Language model, memory, tool, agent. Perfect. Now that we know the core logic of a LangChain workflow, we can make a reusable template with those four components and keep placeholders for any future use for any task. And if my pace feels a little speedy, just pause the video whenever. I promise I will still be here when you hit play again. That's the beauty of YouTube. Alright, here's the roadmap. 7 steps to build a universal LangChain template with LaMTA components. First, we will set up our environment and dependencies. Second will be the language model setup. Third, we will make a universal prompt template. Fourth is going to be the memory setup. Fifth is the tool setup and definitions. Sixth is configuring the agent. And finally, the seventh step is the task execution setup and how we receive the output. As with any code kickoff, we first need to import a bunch of libraries and functionalities such as these general purpose ones. We won't need all of these for today's tutorial, but it's good to get familiar with these functionalities, especially agent type and initializer, tool, memory, prompt template, and LLM-chain. You might have noticed that some of them are directly from LangChain and some from LangChain core and LangChain community. Okay, I need a quick detour again to explain these. When they started in 2022, it was only LangChain library. But as they grew larger, they had to separate these functionalities into 3 packages. LangChain retained top-level main classes for agent, chains, and retrievals. So they packaged other modular abstractions such as language models, document loaders, embedding, and vector stores inside LangChain core. LangChain community is basically all third-party integrations, more for future videos. Before moving to the next step and defining our language model, we need to decide whether we want to use local LLMs, for example, the models you might have downloaded from the Hugging Face, or use a third-party model. I plan to cover the local models in one of the future videos. For this template, I'm using the free version of DeepSeek R1 model from a third-party provider called OpenRouter. So we need to first set up its API key in our environment. This is as simple as making a .env file in our project folder or working directory and pasting your actual key with this format. Without going into too much detail, you can also do this from your terminal and write your key in the .env file like these methods for Mac and Linux as well as for Windows users. I've already covered these steps in my previous videos, so please pause the video if you need to copy them now. Just remember that if you're in development mode, add this .env file to your git ignore so you don't accidentally commit it. Now, all you need to do is import load.env and set your environment path to access this .env file and your API key. This way you don't have to print it in your notebook or main workflow if you're sharing your file like me. Once that's done, we can easily move to the second step and define our LLM like this. It's quite straightforward with these 3 main parameters. Temperature, lower means more factual and higher more creative. Model name for the exact name of the model and max tokens to set the limit for the length of the response. So if you're paying for it, you don't break the bank. Here I'm keeping it less talkative. Since LLMs work with natural language as the user's prompt, in this third step we can set up a universal prompt template skeleton that we can modify for future use cases. Here's where I need to clarify the difference between a simple user prompt and a prompt template. A user prompt is pretty much like what you type into your favorite chatbot each time anew. But just like any good tech whiz would save themselves from a lifetime of finger cramps, you'd want to set up a reusable prompt template if you're going to perform that same task repeatedly. This way, we can keep placeholders or variables like text input, language, task type, etc., then reuse the base across many calls by passing different values. This becomes even more important if you're building an agentic workflow or an app. You want to define the overall LLM and system behavior, how to handle the input or user's prompt, and what to consider when generating responses. For example, this shorter version gives a brief description of a translation task with placeholders for language and user's text, and simply instructs the model to translate the text to any requested language. On the other hand, for this longer version of the prompt template, because it uses the zero-shot agent, LangChain needs to know the rules and the role of the model, the tools it can use, and the actual user's query. This is usually done with a prefix and suffix like these ones. Prefix is the text that comes before the variable part of the prompt. It sets the scene, tells the model what role it's playing and how to behave, and can also include examples or special constraints like a negative prompt. For example, this one says, "You're a helpful assistant that answers questions using available tools. Always explain your reasoning step by step." The suffix is the text that comes after the main instruction part, but before the model starts answering. It can include a call to action or output format instructions. Usually it contains placeholders for the user input. This suffix starts with begin, which tells the LLM to start solving the question inside the placeholders of user's input. The agent scratchpad here is a placeholder where the agent keeps its own reasoning and intermediate tool results and insert them here briefly between runs, like a sticky note memory. This is part of LangChain's React style of reasoning. This way the model can see its own previous thought process and what it did, so it can continue from there. All that is left is to define the prompt and pass these prefix and suffix, the tools it can access, and the input variables. Don't worry, we will plug it all together in a minute, but for now, let's move to the fourth step, memory setup. Memory is basically the way to store your data, including prompts and any chat history. So we can build a context-aware agent that keeps track of past requests and responses. This way, down the line, the agent won't forget the initial conversation or context. This is really important for chatbots and for reducing LLM hallucination. This one is also pretty easy to set up. We can initiate it with a method called conversation buffer memory, which is the basic chat history available in LangChain and is good enough for today's tutorial. Once you decide on the choice of memory, all you need is to define its parameters or just keep them as their default like this. For example, setting memory key to chat history will store previous conversations under the key chat history. You also want to set return messages to true, so you get the messages as objects, not as strings. And define the variable for input key or the user's input and output key for the agent's output. There are other options for the type of memory, such as conversation summary memory, which can summarize all conversations to provide context to the model. Conversation buffer window memory keeps track of only the last n messages. Here you define the number of past messages with the parameter k. This way it only keeps track of recent interactions. Conversation token buffer memory only keeps track of the last n tokens instead of the last n conversations. You can also use vector store retriever memory, which saves past conversations as vectors. And the next time the user has a query, it performs a semantic search through history to find relevant data. Before I move on to the next step, I'd like to clarify that memory in LangChain does not mean database. When you add something like conversation buffer memory or conversation summary memory to your chain, LangChain just stores the conversation in memory or RAM inside that Python object while your program is running. As soon as the Python process ends or you restart your Jupyter kernel, that data is gone, unless you explicitly persist it somewhere. So the memory object is not automatically saved to disk or cloud. In future videos, I can show you how to set up database for persistent memory. But for now, let's get back to our own simple setup, moving to the fifth step or tool setup. Speaking of tools, this step is optional, meaning you don't have to necessarily use a tool in the workflow. For example, if your task can be done by the knowledge of the LLM itself, for example, a question answer chatbot using the training data of the LLM itself, or just writing a post or email, then you can skip the tool part and just make a simple AI chain. But if your agent needs to take an action, for example, to access a web search tool to answer those questions in the first place, or if you need to send your post to an email address, then you definitely need to use a tool in the chain. This is an agentic workflow or application, so keep this distinction in mind. You can use a variety of integrated tools or third-party tools that are compatible with LangChain, like the ones in this page, for example, productivity or web search tools, or simply make your own tools, for example, by writing is Python code within your workflow, like this generic example. For that, we could write a Python function for a tool like this generic tool function, and then use the LangChain's tool class to wrap it as a LangChain tool, give it a name and a simple description, and then pass the exact name of the function you wrote. If you make multiple tools and your agent is supposed to iterate through them, simply add them to a list like this. Let's see an example. This tool decorator is the easiest way to define a custom tool that is compatible with LangChain. This function for multiplying two numbers takes two integers and return their multiplication. Here I'm not using this tool in my tutorial, but the way to use it is to bind it with LangChain's bind tools method to your language model. Now, to call the tool, you can use the invoke method to pass in your question in natural language, just like a prompt. For example, what is 42 by 7? And your agent will use the tool to perform your task. The second method is just to define a function as usual and add it to the tools list using the tool class with the parameters I showed you before. Later on, you simply pass this whole thing to the agent. The cool part is that because your agent is context aware, it doesn't respond to an unrelated prompt like hello and only calls the tool when your prompt is related to that tool. For example, when you pass in two numbers. Something that I suggest you always do when writing your own tool is to handle errors within your function. For example, by a try-catch block or by raising exception like these generic examples. You can also use callbacks which print everything to your console. For example, show LLM calls, tool usage, timing information, and errors. To avoid making this tutorial too long, please pause the video if you need to read all this detailed information I've included. Let's move to the most exciting part of the LangChain workflow, configuring our agent or LLM chain. Now, here's the part I need your full attention, quite literally. Remember that I told you about the difference between a simple AI workflow and the agentic one? Here's where this comes handy. So if you're making a workflow which only requires the knowledge of the LLM itself to perform the task, for example, language translation or summarization, instead of using an agent, you could either just use LLM.predict or simply construct a chain using the LLM chain method in LangChain and pass in the name of your LLM, your prompt, and memory like this, and then use the chain run method to specify domain, task, and input to be able to get the final response. For example, if your task is language translation like this one, you define the set of languages for translation, for example, translate English to Arabic, and then specify the input, which is going to be the user's prompt later on, or an inline request like this one. And of course, you need to print your response. But, and this is an important but, if you have already specified one or more tools, either internally defined or an external one via API, then instead of a simple LLM chain, it's better to make an instance of an agent with the initialize agent method like this generic example, because now you have an agentic workflow. Technically, the LLM chain works both for simple LLM workflows as well as agentic ones that can access tools. But the point is that LLM chain literally works like a direct sequence or linear chain, where the output of the tool is used as input to the next step in the chain, invoking one tool at a time. But the initialize agent function uses a powerful class called agent executor under the hood that can reason which tools to use for which purpose and can handle multiple tools at once for more dynamic and complex tasks. The parameters are quite straightforward and easy to understand. You pass in the variable names for your LLM tools and memory. You can also set the verbose to true so you can see the model's thinking process, but I suggest you set it to false for the production. You can also handle the errors gracefully by setting it to true and set the maximum number of times you want your model to attempt a query before executing it and giving your response by this max iterations parameter. Please don't set it to none or your agent will loop through your chain infinitely. Just saying. As always, best for the last. This is how you set your agent type. The zero-shot React description agent is a good option for general-purpose reasoning tasks with step-by-step reasoning. The conversational React description is a better option for chat-based interactions. Use this agent with extremely short name, structured chat zero-shot React description for more complex tasks that involve both chat and reasoning. And finally, use the self-ask with search for research and fact-finding tasks. Finally, you can pass in a keyword argument such as the prompt you've already set with the system message and task description. This way, your agent has access to all components it needs to run your task. All is needed now is the seventh step or configuring the execution of the task. We've already saw how to do this for running the LLM chain using the chain run method. For an agent, you use agent run. Yep, that's simple really. So, use natural language to describe your task and store the output as a response or output. You can also use the simple method called agent to pass in the key as the user input that we defined before, and its value would be the description of the task, and simply print the response. I know it looks like a bit overwhelming so far, but trust me, once you set up this template, all you need is to reuse it and just change parameters or add components for any other task. I'm leaving more advanced methods for future videos, but now let's see this whole template in practice with a hands-on tutorial. We will go through two workflows. One using the LLM chain with the knowledge of the LLM itself for a summarization task, and the second is an agentic workflow with a math tool. Because I've already explained all these variables, I'm going to just run them with a brief description of the task, so pause and follow along at your own pace. First thing first, install these dependencies. Then set up your API key if you're using a third-party LLM. I'll be using DeepSeek R1 from OpenRouter, which is compatible with Chat OpenAI clause. For this one, you need to set an OpenAI API key, but paste your OpenRouter key in front of it. I hope this is not confusing. You also need to point to the OpenRouter URL when specifying the OpenAI-based URL, as you can see. Load your key like this and confirm if it's loaded without printing it. For the first workflow, we will use this reusable template for a summarization task, which only needs the LLM itself, prompt template, and LLM chain. Now, define your LLM as before and set the temperature. I'm keeping it low not to run out of token credits. We define a one-line template just to instruct it to summarize the text in one sentence only and keep the text placeholder, and then point to this in the prompt using the prompt template clause. Building a chain is as simple as setting this LLM chain with LLM and prompt. Now, you can easily pass in your text like this and finally use the chain run to run the task and print the response. Here is the summary in one sentence. It looks pretty accurate even though it's a long sentence, but feel free to play around with different text and parameters on your own. As you can see in this warning, LangChain is deprecating LLM chain and using runnable sequences. They are also deprecating chain run and using invoke instead of it. In future videos, I will show you these adjustments too. But these are still working, so for now let's move on to this second workflow, which is an agentic one. It uses a tool called LLM Math from LangChain to calculate the square root of 5,784 rounded to 2 decimal points. This LLM Math tool is part of the Load Tools class in LangChain with an integrated set of widely used tools and functionalities. Very handy for this type of workflows. I'm keeping it simple for this introductory tutorial, but you can experiment with its other tools on your own. Everything else in this agentic workflow is pretty much the same as what we learned before. Just use the agent run to define your question. As you can see, the first time I ran this, it threw an error because I forgot to include handling errors in the agent, but nevertheless, it still gave the correct answer. Here I'm running it for the second time, including handle parsing errors and setting it to true. This time it gives a faster and more concise answer, even though the answer is the same. You can experiment with other examples and let me know how it went for you. To wrap it up, with these universal and reusable LangChain templates I showed, you can use two types of workflows. One with the knowledge of the LLM itself and without tools. For tasks such as summarization, text generation, and most types of translation tasks, doing your homeworks automatically. Just kidding. I mean, you could try, but don't blame me if things go wrong. The second type of workflows are agentic ones with one or more tools using the initialize agent method. It's quite literally the end of the video. If you've come so far, it means you love my channel so much that you're ready to watch this related video too.